for lesson 9, we're going to begin our process of completing the square, which is going to be an additional way for us to solve some of our quadratic equations. So far we've learned factoring. In the previous lesson, we learned our inverse operations. And the third of our fourth solving method is going to be completing the square. But we have to do a little bit of background work first before we get to how the process actually helps us in solving. So in the opening exercise, express each of the perfect square binomials as a trinomial in standard form. So in other words, we know that x plus 3 squared is really x plus 3. So then what we're going to do is we're going to multiply out our x3. So we're x squared plus 3x plus 3x plus 9. So we have our like terms here. So we have x squared plus 6x plus 9. And what I want you to do now is pause the video, and I want you to repeat that process for the remaining two. So as we do this for the next two, we end up with our x plus 5 and x plus 5. So x squared, 5x, and 25 gives us x squared plus 10x plus 25. And then for the last one, we are x plus a and x plus a, so that gives us x squared. X times a is ax, x times a again is ax, and a times a is a squared. So we got to be a little bit careful here as we combine our like terms. Ax plus ax is 2ax, and then we are plus a squared at the end. So that's just a quick little review of our multiplying. And the idea of this perfect square binomial and perfect square trinomials are going to be important for today. So now the first one wants us to factor each of the following trinomials. So again, I want you to pause the video and take a minute and factor all of those into your two equivalent parentheses. So as you do that here, we know we're going to draw our boxes. First term top left, last term bottom right. So we're going to multiply our 1 by 36 and adds to 12x. What does that? So 6x and 6x. And as we GCF, we get x and x, 6 and 6. So then we end up with x plus 6 times x plus 6. Now it's not equal to 0, so we don't have to solve. But I just want to point out too that when you have the same parenthesis twice, that's equivalent to having x plus 6 in parentheses squared. So the middle looks almost exactly the same. The only difference is we now have to multiply to 36 and add to a negative 12. So when we do that, we get negative 6x, and as we fill around our boxes, we just end up with x minus 6 for both of our parentheses, and then we get x minus 6 squared. And our last one, x squared top left, 100 bottom right. Multiply, so multiplies to 100 and adds to 20. That would be 10 and 10. So as we fill out our boxes and get our parentheses, we're x plus 10 and x plus 10, or x plus 10 squared. So these are all known as perfect square trinomials. Okay? And the reason is they produce the same parentheses when factored. Okay? So if you have a trinomial that is factored and you get the same parenthesis twice like we did for all three of these, then it is known as what is called a perfect square trinomial. So can we factor the trinomial x squared plus 8x plus 3? And then we want to write an equivalent expression to that by completing the square. So if we look at this first part here, can we factor this? The answer is no. Nothing multiplies to 3 and adds to negative 8. So now what we're going to do is we're going to do the process of completing the square. Okay, so the first thing you want to do, step one, you want to add 2 lines to your problem, and they go in the same spot every time. So we're going to be x squared plus 8x, and then that's going to be where your first line goes, and you're going to wrap that piece in parentheses. Then you'll keep your plus 3 on the outside, and then you're going to have to do minus a line. Okay, so the first line is always going to be plus, the second line is always going to be minus. Second step, take the number in front of your x. Okay, you're going to divide by 2, and then you're going to square that number. So we have 8 divided by 2, which is 4. And then if we square that number, we're going to get 16. Okay, so that number is going to be important because that number goes on both lines. So that number goes on both lines. So we get x squared plus 8x plus 16, still in parentheses. And then we are plus 3 and minus 16. So again, that first line is always a plus, that second line is always a minus. Now the reason we did this is because this parenthesis right here that we've created, the x squared plus 8x plus 16, is always a perfect square trinomial. All right, so we know when we factor that piece, we're always going to end up with the same exact parenthesis twice. Okay, so if we go about the process of factoring that piece, we have x squared and 16. So what multiplies to 16 and adds to 8x? We'd get 4x and 4x. So we get x plus 4, x plus 4. So we have x plus 4. And again, you could write it twice, but realistically, you always know you're going to have it twice. You just have that one parenthesis squared. So x plus 4 squared. And then you're going to take those two numbers that are on the outside and you're going to subtract them. So 3 minus 16 gives us a negative 13. That right there is going to be our equivalent expression by completing the square. Now we'll talk in later lessons on how we actually use that to solve, but this is the process of completing the square. So just to write out then what to do for step 4, you want to factor your parentheses and combine like terms. Okay, so everybody should probably pause the video for a second here and take a look at that process over again as we move into our next ones. So as we move on to number 3, we want to write equivalent expressions for each of the following by completing the square. Okay, so remember, our first step is to add 2 lines. So that first line is always a plus, we wrap it in parentheses. Then that 15 goes outside and it's minus a line. So that was step 1. Step 2 was to take the number in front of the x, divide it by 2, and then square it. So in this case, we got to be careful with our signs here. The number in front was a negative 4. So negative 4 divided by divided by 2 is negative 2. And then when we square negative 2, we get a 4. Our third step said that number goes on both lines. So then we end up with x squared minus 4x plus 4. And then we end up with plus 15 and minus 4. So now we're going to go about the process of factoring that trinomial that we just created, but I want to give you a little bit of a shortcut here. If you notice, what was the number that we got in our parentheses? It was x and then plus 4. Well, when we divided that middle number by 2, what did we get? Well, we got a positive 4. So those numbers seem to match. Well, when we divided by 2 here, what did we get? We got a negative 2. So what's going to go in our parentheses is going to be a minus 2. So that number, end sign, okay, positive or negative, matches the number from dividing by 2. Okay, and then we're going to add, and then we're going to subtract this stuff on the outside. 15 minus 4 is 11. So there's our equivalent expression by completing the square. X minus 2 squared plus 11. As we try the next one here, x squared minus 2x minus 15. Well, again, we're going to start by putting our lines in. So x squared minus 2x plus a line. Careful with your signs here, minus 15 minus a line. So now we're going to take that middle number, divide it by 2, so negative 2 divided by 2 is negative 1, and then we're going to square it to give us a positive 1. So we put a 1 on both of those lines, plus on the first one, minus on the second one. So again, we're going to factor this here. But if you're using the trick that we just established, what was the number we got when we divided by 2? We got a negative 1. So our parentheses should read x minus 1. And we'll be careful here. Negative 15 minus 1 is a negative 16. So then our final answer by completing the square here is going to be x minus 1 squared minus 16. And again, we're going to learn how to do the solving with this soon. Right now, we're just establishing the process for completing the square. So now I'd like everybody to take a second and pause the video so that they could work on the remaining 5 pieces here by completing the square. So as we jump back in, x squared minus 3x plus 10. So hopefully you're starting to get the pattern here of where your lines go and where we're getting those numbers from. Now if we look here, we end up with a little bit of a different problem here. Now you have the option to either put these in decimals or in fraction form. It's kind of up to you. So I prefer to keep them in fraction form. So we get negative 3 over 2 squared. And then when we square that, again, it's just easier if we go to our calculator. So if we go alpha y equals negative 3 over 2, and we want to square that, and actually I really should have wrapped this in parentheses first. So now if we want to square that piece, we end up with 9/4. Okay, so we get 9 over 4. So then we're going to fill in our lines, x squared minus 3x plus 9 over 4, and then plus 10 minus 9 over 4. So now, again, this looks pretty bad to factor, but if you just remember what the rule was, it says you take the number you get when you divide by 2. So since we got negative 3 over 2, we're going to have x minus 3 over 2 squared, and then just do 10 minus 9 divided by 4 in your calculator, and you get 31 over 4. Okay, and again, I said you could do this with decimals or fractions. So if I just quickly show you what it looks like in fraction form, when you divided, you would have gotten negative 1.5, which when you square it gives you 2.25. And again, that is just calculator work. All right, let your calculator do the work. And you can see I made a mistake there by putting or forgetting to put it in parentheses because it gave me a negative number. So I know that I should get a positive 2.25 for this. So I'll have x squared minus 3x plus 2.25. And then plus 10 minus 2.25. Okay. And now again, my parentheses still going to look the same. I'm going to be x minus 1.5 squared, right? Because that's the number I got when I divided by 2. And then out here, if you do 10 minus 2.25, you get 7.75. 5. All right, so these two here are the same. It's just a matter of if you want to keep it in fractions or you want to keep it in decimals. For x squared plus 20x minus 40, x squared plus 20x plus a line minus 40 minus a line. So we take that middle number, 20 divided by 2 is 10. 10 squared is 100. So we're 100 on the inside, 100 on the outside. You get x. It's a positive 10, so plus 10 squared. And then negative 40 minus 100 is negative 140. So there we get our equivalent expression completing the square, x plus 10 squared in parentheses minus 140. X squared plus 8x. Now it looks weird because normally we should have something at the end. So if there's nothing there, what is it really? It's plus 0. So we've got x squared plus 8x plus a line, and then we're plus 0 minus a line. Now, do you have to put the plus 0 in? No, it's just kind of a placeholder to make everything look a little bit more familiar. So 8 divided by 2 is 4. 4 squared is 16. So then both of our lines are going to have 16s on them. So we know this factors into x plus 4 squared, and then 0 minus 16 is a negative 16. In the middle, x squared plus 7x plus 6. So x squared plus 7x plus a line plus 6 minus a line. 7 divided by 2 is, and again, you could choose to keep this however you want. I found a lot of the times the Regents likes to give their answers to questions like these, multiple choice wise, in fractions. So I'm going to keep them then as fractions so we get a little bit more used to that piece. The decimals, I feel like in general, are just easier for you guys to work with. So then, if we take 7 divided by 2 and we square it, there would be your decimal. Math, enter, enter. You get 49 over 4. So that's going to be the number that goes on each of those lines. Right? And again, I know that it's a little weird because we haven't solved for anything yet, but I promise you we will get to that piece with this. So we get x, and then we're plus 7 over 2 squared, because that's what we got when we divided by 2. And now we're going to be 6 minus that 49 over 4. And again, we're going to keep this in fraction form, and we get negative 25 over 4. Okay, so again, we're just kind of going throughout our process here. It's the same process over and over and over again. It's just a matter of getting good at dealing with some of the fractions and really just kind of committing this process to memory. So as we keep getting into this, all right, actually I'll do this one, just a little bit of a change up here. I'll do this one with decimals. So 2.5, then we will square the 2.5 and get 6.25. So that'll be the number that goes on each of our lines. So as we continue to fill this out, okay, you should know what your parentheses squared looks like. So it's x plus 2.5, close parentheses squared. And then if you do 3 minus 6.25, you end up with negative 3.25 is our equivalent expression. So again, you can see evens, odds, positive, negatives. The process is still the same over and over again. We just got to kind of get good at what that process is and how it actually works. We want to write two equivalent expressions to r squared plus 4r plus 3 by factoring and then by completing the square. So let's look at our factoring piece first. So if we have r squared plus 4r plus 3, everybody should be able to do this on their own. So we know r squared and then 3. We have our 1 in front, we multiply, so multiplies to be 3, adds to be 4. Well, what does that? Well, that's 3r and 1r. So as we start to build our boxes, we have an R, 3, and 1. So we have R plus 3 and R plus 1 as our two parentheses, excuse me. So they didn't ask us to solve, they just wanted equivalent expressions. So when we factor, those are our equivalent expressions. So now if we look at this by completing the square, what does the first step say to do? Well, we have to add our lines where they belong. So now, middle number divided by 2. 4 divided by 2 is 2. 2 squared is 4. So we fill in a 4 on both of those lines. Okay, you could start to fill them in above so you don't have to write it over and over again. So then what do we end up with for our 1 parentheses squared? Well, we know it's R plus 2 because the number we got when we divided by 2 was positive 2. And then positive 3 minus 4 gives us a negative 1. So these right here are equivalent expressions. Now they look very different, but as we start to learn how to solve with the completing the square piece, you'll see that these end up producing the same exact answers for us. Explain why we cannot solve x squared minus 8x minus 7 equals 0 by factoring, and then complete the square on x squared minus 8x minus 7 to see how the process can be used to solve quadratic equations. So the reason we can't solve that is because nothing multiplies to negative 7 and adds to negative 8. So since there are no options for that piece, we have to choose a different method. In this case, we're going to be completing the square. Now the only thing different about this is we're just going to kind of keep this thing equal to 0 as we go through our process. So x squared minus 8x plus a line, minus 7 minus a line, and that's going to be equal to 0. So we take our middle number, negative 8 divided by 2 is negative 4, squared is 16. So on both lines we get that 16. Our parenthesis reads x minus 4 squared, and then negative 7 minus 16 is going to be a negative 23. Now, like I said, we're just keeping the equal to 0 piece because what this turns out to, and we'll worry about solving this more in the next lesson, is this turns out to then be solved by inverse operations. So everything that we learned in the previous lesson is now what we're going to do to end up solving these starting in our next lesson. Okay, but again, today is really just about you feeling comfortable with the process of completing the square. Gina tried to complete the square on x squared minus 12x plus 7 and got x minus 6 squared minus 29. Are these two expressions equivalent? Well, we know that this looks like something that came from completing the square, but let's actually complete the square to this problem and see if we get what she got. So we take our negative 12 divided by 2, we get negative 6. Negative 6 squared is 36. So 36. We know this turns into x minus 6 squared is our parenthesis, and then 7 minus 36 is negative 29. So the answer to the question is yes, these two are equivalent. All right. So Gina followed the completing the square process correctly and got an equivalent expression for x minus 6 squared minus 29. And that's going to be our introduction here to our completing the square.